Let's revisit the derivative of this function right here. Well, it might not be exactly like I had it earlier, but I just made a polynomial function. This is a trinomial. It's quadratic. For me to differentiate, use my definition. Here's the limit of the difference quotient, and here's what I get. We don't have to do this anymore, because technically speaking, we have all the shortcuts that I have on the other side of the board that's no longer here, apparently. So with that big collection of shortcuts that you and I just derived out of thin air, let's just use those shortcuts. So I guess what I'm trying to say is this. To differentiate this is to differentiate with respect to x this expression here. But one of my shortcuts says to differentiate the sum of two functions, I get their individual derivatives. To differentiate the difference of two functions, I get the derivatives of individual terms. However, to differentiate a constant times a function, I get that constant times the derivative with respect to x of that function. I'll apply the same shortcut here. But that's going to give me 2 times the derivative of a power expression. So using that rule that I had, I'll wrap my fingers around the 2, pull it down to the level of everything else by multiplication, and reduce the exponent by 1. Now, I told you how to differentiate a linear expression, but we don't have to look at that rule. We can just simply use that rule that says to differentiate x to the n, bring the n down, reduce the exponent by 1. So in doing just that, this exponent is 1. I'll bring it down. Reduce the exponent by 1. So reducing the exponent 1 by 1 gives me x to 0 power. That's just 1. And I have that lingering 3 out front. And lastly, to differentiate constant simply gives me 0. That being the case, I'm left with this. Gee, that really didn't look a lot shorter than what I had with the limit of difference quotient. So can I redo this? I don't like it. I still think I did way too much work, but it was my first example applying all these rules. So now let me show you what I actually write. If f of x is, my goodness, can I remember it? I think it was 2x squared plus 3x minus 5. For me to differentiate, I will bring the 2 down, reduce the exponent by 1. Take the understood exponent 1, bring it down. Reduce the exponent by 1, but that'll give me x to 0 power is just 1. And the differentiated constant simply gives me 0. If you don't like the way I say differentiated constant always gives me 0, think of it this way. That's 5 times x to the 0 power. So now when I use that rule that says bring the exponent down, I get 0 times stuff, which is just 0. Now, before I move on to another example, I have to confess, everybody, I'm stumbling on my words. So if you don't mind, let's go back very quickly to that one rule that says if I differentiate with respect to x, a power expression like this, we'll wrap our fingers around the exponent, bring it down to the level of everything else by multiplication, and reduce the exponent by 1. When I created that list for you, I should have given this a name and I didn't. So because I don't want to use so many words from here on out, I'll refer to this as my power rule. I will often say my power rule for differentiation because technically speaking, before the semester is over, we're going to talk about undoing it. And therefore, I'll have another power rule for anti-differentiation. I'm getting ahead of myself. For now, I just have this power rule for differentiation.